Hello guys! In order to realize the communication between different devices, the organizations propose the reference model, and the typical one like OSI reference model by the ISO organization and TCP/IP reference model by the IEEE. And about this part, first we will understand the basic background of these two reference modes. And the second one, we will realize the OSI reference mode at first. It is divides the network into different hierarchical structure. So, about OSI reference mode, we have 7 layers. What's the name of each layer? What's the typical protocol of each layer? And what's the function of each layer? After we add the information of the date, what's the protocol name of the packets? So if you are interested about these questions, please discuss together.
Hello everyone. Before we talk about the detail of OSI reference model, let's have a feedback of the last video about the practice question. Which of the following statements about star topology is incorrect? The answer is option C. The star topology has high reliability and there is no single point of failure problem. Actually, the star topology is better than the bus topology, but there also is a single point of failure. I think maybe you also remember all the devices were directly to connect with the middle device. If the middle device is broken, the communication is broken. So this one we call is a single point of failure. And then let's see the OSI reference model. Why we need the reference model? That's because with the rapid development of the network, many manufacturers will create the different hardware and software. But maybe they have to communicate with each other. For example, in the company, I buy the Cisco router and also I buy the Ruijie switch. We have to communicate with each other. But if different manufacturers transfer the packets according to their own agreement, the communication maybe have some problem. That's why we need some organization like ISO and IEEE to create some reference model, and the different manufacturers can create different device. But if they want to communicate with each other, we can have the same rule. And the typical reference model, one is OSI, created by the ISO, and another one is the TCP/IP, created by the IEEE. First, let's focus on the first reference model. About the OSI reference model, we divide the network into different hierarchical, different layers. So, what's the advantage? The advantage of layered structure, the first one is open standardized interface. For example, what's this mean? Now maybe I think everyone has a phone, right? And the common phone like the iPhone. And about the iPhone, we have different series. But the typical interface is power. We can use the same power to provide for different iPhones. So this is the standardized interface. Also in the network, the router with Cisco and the switch of Ruijie. If we use a traced pair to connect with the electric interface, they also can communicate with each other. So if we have the standardized interface, multi-vendor can provide the compatibility. They can directly to communicate with each other. And for the beginner, for us, for students, if they want to know some knowledge of the network, the hierarchical structure also is very helpful. Easy for us to understanding, learning, and updating protocol standards. For example, today I want to learn the first layer, tomorrow I want to learn the next layer, something like this. And for the engineer, it's easy to troubleshoot. For example, now maybe I am the engineer of the company, and the customer say, I cannot with the internet, please help me. So you can use the layered structure. For example, first I want to check the first layer about the physical layer is correct or not. Maybe it's a cable, the lighter is green or not. If this layer is okay, then I will check with the next layer. Maybe I will check the network card to check the IP address, to check the MAC address, something like this. And finally, I will check maybe is the application is broken, something like this. So for the engineer, it's very easy for us to do the troubleshooting, especially the first time you meet the problem. So this is the advantage. Then let's see the detail of the OSI reference model. We say we divide the network into different layers, right? So what's the name of each layer? About OSI reference model, we divide the network to become 7 layers, from bottom to up. The first layer is the physical layer, data link layer, and finally it's the application layer. And each layer will have the different function. Let's focus on the first layer of the application layer. Provides the inter-application communication. This layer is directed to communicate with the customer. As we know, not everyone knows what means network, right? For example, I know what means network and I know what's the function of IP address. But about my family, they only use the phone, maybe use the laptop to shopping online or to see some movie. So about the application layer directed to provide the application like YouTube, like Facebook, and then we can use this application to meet some requirement. And I can use Facebook to send some message and everyone can see this message. And the next layer is the presentation layer. Handles the data form, data encryption, and the executor. The data form means, for example, now maybe I use the phone to update a message on the Facebook. But the other one maybe use a laptop to see the message. So about this layer will deal with the form of the device. That means different devices, all of us can see the same message. And the data encryption is used to help to protect the data. Okay, the next layer is a session layer. Session layer establish and maintain the message session. For example, I have so many friends in the Facebook, and now I will choose to establish one session with one friend. So this is the session layer function. I have to establish the session and then to maintain the session and then send the message. After this part, I will delete the session. The next layer is a transport layer. I have to establish a host end-to-end connection. What mean end-to-end? About the application layer, we say we have so many different applications, right? Like the Facebook, like the YouTube. But about the computer, this device only recognizes the number. So we have to use different number to indicate the different application for the computer. For example, maybe the Facebook number is 10, the YouTube number is 20. So this is the main point of the transport layer, and later we will explain the detail. We say one is a port number. And so many people maybe already use the port number. For example, you use the HTTP to open the URL, the port number is 80. But if you use the HTTPS, the port number is 443. And then we have to transfer the packet from the source host to the destination host, right? I upload the video on my computer, but your device also can receive this video. So different devices will have one address to indicate the device. This address is IP address. So this is a function of the network layer, addressing and routing. Addressing means we will apply one IP address for one device. And then the network will have so many layer 3 or layer 2 device. About the layer 3 device like layer 3 switching or the router, we will according to the IP address then for the traffic. So this is a process of routing. And the next layer is the data link layer. Provide a media access, link agreement, something like this. Because we also have to use a cable to connect with different devices, right? And how to make the message to become the bit, something like this. And what's the different protocol between different cable, like the fiber, like the three-piece pair, something like this. So this is a function of the data link layer. And finally, the packets will become the bits like 010101, like the binary bits, and then the packets will be transferred into the cable. So this is a function of the last layer, physical layer, to provide the bit streaming. So from bottom to up, from the first layer to the 7 layers, we have to know the name, the main function. And later I will explain the detail of each layer. And before we transfer the packets, the main process, one we call is encapsulation and another one is the decapsulation. So what means encapsulation? Before we use the network, I think maybe everyone use the letter. For example, I send the letter to my friend on the Christmas day, right? And besides the detail, for example, I hope you have a good day and I hope something like this. And then I will add the friend's address, family address, and maybe the ID number, maybe the phone number, and I also add my information on the letter. Then someone can help us to transfer the letter to my site and then to my friend's site. So this is the information before we send the letter to my friend. Also in the network, before we send the message to the destination, we also have to add some messages. Then the device in the network can recognize this information and send the packet out. So in different layer, we will add some different information. This process we call is encapsulation. For example, now I give you a sentence. Welcome to see the Ruijie training video. Then this message, I hope everyone can see this information, right? Then before this message sent out from my computer, I have to add the application layer at first, right? This is the layer 7 header. For example, I choose Facebook to update this message. And then I will add the presentation layer, session layer, transport layer, network layer, right? So about the network layer, I will add the information of source IP address and the destination IP address. So this one indicates the message from the computer A maybe to the computer B. And then we will add the layer 2 information of the data link layer. We will add the MAC address. This is a typical address of the data link layer. The data link layer is very similar like the family address, or maybe you can think this is your ID. And different device will have the unique ID. Okay, so that's two parts. And finally, we will become the base and send out to the destination. So this process from the first layer to the last layer, this process we call is encapsulation. And about the receiver, before the receiver, we will use a bit to transfer the packets out. And then the receiver receives this message. About the receiver, I only want to see the message. For example, that means I only want to know the message is welcome to see the Ruijie training video. I don't care about what means the source IP address. I don't care about what means the MAC address. So we have to do the process is de-encapsulation. We will delete the layer 1 information and then to provide this message to the up layer. About the data link layer, I also will recognize and then delete the layer 2 information, then to provide the message to the up layer. And finally, Each layer will delete the header and finally to provide the date to the customer, to the receiver. So this is a process of de-encapsulation. In the all network, all the message we send out, we have to do the encapsulation, and about the receiver, we have to do the de-encapsulation. Finally, the receiver will see the data information. So this is the main process. And each layer, we will use the own protocol. And then the up layer will use a service from the low layer. So let's say an example. Now maybe host A wants to send a message to host B, and the host A will do the encapsulation, right? Add the application layer, then add the presentation layer, finally to become base, and then to transfer to host B. And after we add the application layer, this package we say is APDO, Application Layer Protocol Data Unit. And add the presentation layer is PPDO. The session layer is SPDO. This one is very easy to remember, but the different one is if we add the transport layer, that means we add some port information and to indicate different application, right? For example, do you remember? We say maybe we use the port number 10 to indicate the Facebook on your computer, but the port 20 indicates to the YouTube. And after we add the transport layer, this package we say is segment. And after we add the network layer, this message we say is a packet. And the next layer is a frame, finally to become bit. And what means the second sentence? Each layer communicates with the peer layer using the service provided by the low layer. About the host B, if the transport layer wants to know the port information, right? Because I want to know the port number, then I will provide this message to Facebook, not about the YouTube, right? So I have to do the de-encapsulation in the network layer because I don't care about the IP address. I only want to know the port number. So the network layer will do the de-encapsulation to delete the network layer header, to delete the IP address information, finally to provide the port number to the transport layer. So this is the sentence main, the communication with each peer. Okay, so this is the peer-to-peer communication. Then let's focus on the each layer detail function. The first one is the physical layer. And about the physical layer, the main function is define the voltage, interface, cable standards, transmission distance, something like this. So this is a function of the physical layer. For example, maybe in different scenario, if we use different interface or different link, the voltage is different. So what's the detail one? It's indicated from the physical layer. And about this layer, we have the physical layer medium like the coaxial cable, twisted pair, and fiber. These three types belong to the wired cable. And besides this one, we also have the wireless cable like the Bluetooth. And also maybe in the future, we will talk something about the WLAN. So this is the physical layer. Of course, in the physical layer, we also have some device, not only about the cable. We can use some sub device and some media device. Okay, and this is a physical layer. And the next layer is a data link layer. About this link, the function is the first one is framing and identify frames. What's mean? Because about the data link layer, we have to receive the service from physical layer, right? But about the physical layer, I only transfer the packets according to the bits. That means you only see the number of 0, 1, 0, 1, 0, 1, something like this. But about the data link layer, I have to do the framing, for example, to keep the sequence. And from the first bit to the 8 bits, what's mean of this part. And the next part was main. So I will give the sequence number. So this is a framing. And the indicate framings means I also will delete the data link pair information. That means I will recognize the MAC address information and then to delete this one and then provide the series for the upper layer of the data link of the network link. The second function is data link establish, maintains, and release. Before we transmit the packet, we have to establish the data link layer to keep the transmission successfully. And in this process, we also have to maintain. That means I have to detect the link is ready or not. And after we transmit successfully, we have to release the data link. And the next one, we can also provide some error verification. That means if some bit is wrong, we can have some mechanism to let the sender retransmit the message. And also have the function of addressing. About this part, we have a typical address. This address is MAC address. And about the MAC address, we have some typical characteristic. What's the number, how long bits, and what is the mechanism if we receive this message, how to forward the packet. About this part, we will talk about later. Okay, so these are two main layers. One is physical layer, and another one is a data link layer. Then the next part is the network layer. And about this part, we have so many information have to talk. So this is the first video of the OSI reference model. The next part we will talk later.